Hello, in this video I'm going to be going over Bronsted-Lowry acids and bases. But before I do, I want to first talk about Arrhenius acids and Arrhenius bases. This is simple. If it has an H in it, like this, it's an acid according to Arrhenius. If it has an OH in it, it is a base according to Arrhenius. And this works in most situations. But just like most other rules in chemistry, there's always exceptions to the rule. Ammonia being one of those exceptions. So, well, it kind of has an H in it, so it should be an acid, and it doesn't have an OH, so it couldn't be a base. However, ammonia is in fact a base. When you test it with pH or litmus paper, it turns blue, or signifies it being having a pH of 7 to 14, which would be basic. So Arrhenius' model does not completely fit every single situation. It wasn't until Bronsted and Lowry, a Danish chemist and a English chemist, they both lived separate places, didn't talk to each other, and they came up with a similar idea, and so were both credited with this concept. So what a Bronsted-Lowry acid is first of all, it's a proton donor, also known as an H+ donor is an acid, and an H+ receiver is a base. And it's all about where the H+ is going. Alright, so doing an example right here, why don't we start with number 2, since it's a little less confusing than number 1. Number 2, we have H2SO4 plus OH reacts to form HSO4 plus H2O. So H2SO4 we know is going to turn into HSO4. Zoom up on this guy. So if H2SO4 turns into HSO4, that means it needs to lose an H+. So it's losing an H+. And if it's a loser of H+'s or a donor, it's an acid. So we're going to put A for acid right there, and then by default the other guy is going to have to be a base. But we can look at this. OH- turns into H2O. What needs to happen? It needs to receive an H to have that occur, and H+ receiver is a base. Alright, so now there's an equilibrium arrow, so it can go both ways. So we have HSO4 turning into H2SO4. It needs to gain an H+ for that to happen. So if it's gaining an H+, it's a receiver, so therefore it's a base, and we call that the conjugate base because it's on the product side. And this water turning into OH-, it loses an H+, so we call that an H+ donor, or an acid, Bronsted-Lowry acid. So we got acid base, conjugate acid. The acid is always going to turn into the conjugate base, and the base is going to turn into the conjugate acid. And really, if you figure out one, like if you find that this is the acid, then you know it turns into the conjugate base. And if this is the acid, you know the other one has to be a base, the other reactant. And the base always turns into the conjugate acid. So really you just need to find one, and then you can find the rest, if you know the general trends. So doing one more, we have HSO4- turning into SO4 2-, just lost an H+. So it's losing an H+, so therefore it's an acid. And this water, of course, would have to be a base because it's H2O to H3O, it's gaining an H+, it's a receiver. Looking at this SO4, to turn into HSO4, it needs to gain an H+, so it's going to be a receiver, conjugate base. This H3O is giving to form water, so it's conjugate acid. And that's Bronsted-Lowry acid-base, conjugate acid-base pair. Alright, why don't we do a problem from the other side? These aren't too bad. It's just sometimes it's helpful to see an example, see how one's actually done. We have H3PO4 right here. we want to figure out what its conjugate base is. Its conjugate base is just the same thing as the acid, only with one less H plus because it lost one. So this guy with one less H plus is H2PO4, and if it lost an H plus, like this is still phosphate minus 3, and this is hydrogen's plus 1, but there's 2 of them, so it's 2 plus. 2 plus 3 minus is minus 1, so it's an overall minus charge. Or you could think a neutral zero charge, when you're losing a positive, now it's going to be one more negative. And when we write this, we're going to write H3PO4 reacts to form H plus H2PO4 minus. Zoom that out. Alright, doing one more. This is F minus. It's a base, so it's a receiver of H plus. Once it received its H plus, it's now HF, which is an acid. Acids always start with an H. If they don't, then it's not an acid. So we would rewrite this as HF, equilibrium arrow, produces H plus plus F minus. And that is a conjugate acid-base pair.